Good morning, Honors Math 2. Today we are going to spend some more time on our third conic section, which is an ellipse. You should find this page in your module, 8-7, Day 2. Yesterday we constructed our third conic section, an ellipse, and we used that definition in terms of distance. Today I'm just going to move my major axis so it's vertical. That means that my two focus points, my foci, will be on that vertical axis. And we defined an ellipse this way, that an ellipse is made up of any point, the sum of whose distances is always a constant. So that distance plus that distance is always the same as that plus that, which is the same as that plus that. And the sum of those distances is always the same from two fixed points, and we call those fixed points the foci. The set of all points, the sum of whose distances is always a constant. Okay, so if my foci are on the vertical axis, then my ellipse is going to be stretched more vertically. And then we defined many things in this ellipse. Remember that the distance from the center to a point on the ellipse is that horizontal distance A. From the center to the edge of that ellipse, we call that vertical distance B. And the distance from center to focus we define as C. Please notice now this string, if I'm vertical, has a length of, actually that sum is going to be 2b if my ellipse is more vertical. So now the sum of that distance is 2b. We're going to talk about the length of those segments today a lot. Please notice if my major axis is vertical, B is the largest of those A, B, and C. And if I were to stretch that straight out to the left, then this segment would just be 1b if I could stretch that. And that distance from focus over here would be B, and I get that little right triangle where B is that hypotenuse. We might come back to that in a moment for a visual. Okay, please find this page in your module. Okay, please use this as a reference. If the center of my ellipse happens to be at the origin, and my foci then are on that, in this case, that horizontal axis, my ellipse might look like this. And if the center is at the origin, then we get a simple equation of an ellipse of x squared over a squared plus y squared over b squared is equal to 1. The center of my ellipse does not need to be at the origin. Let's say the center of my ellipse is somewhere else, HK. My ellipse does not have to have a major axis that's horizontal. If my foci are above and below the center, then the major axis is going to be vertical. And if my center is not at the origin, then the general equation will look like x minus h squared over a squared plus y minus k squared over b squared, always equal to 1 in standard form. Now you can label a couple things. Remember the distance from center to focus is always c. The distance from center to the ellipse going horizontally is a, vertically is b. Horizontal to the point on the ellipse is a, vertical to a point on the ellipse is b. If you want to label a couple of things, and we'll define a, b, and c. Okay, a was the horizontal distance from the center to the edge, b is the vertical distance from the center to the edge, and c is always the distance from the center to the focus. We get these important properties that we'll use a lot. With a major axis that is horizontal, major axis. Please notice that A is the longest. I get this right triangle in the middle, which has sides of B and C and a hypotenuse of A. So we will use B squared plus C squared equal to A squared if I have a horizontal major axis. But if my ellipse is turned, then I get this little right triangle in my ellipse, which has legs of C and A and a hypotenuse of B. a squared plus c squared is equal to b squared if I have a vertical major axis. I'm going to pause a lot here so that you can try a few problems on your own, and then I'll kind of guide you through a few things. But use those as a reference if you would. All right, thanks for working through some things with us, and keep pausing as you go. I'm going to ask you to sketch the graph of this ellipse here, and then we're going to find the foci. Remember, C is the distance from the center to the focus. Alrighty, start to sketch this ellipse. Please find A and B and the center, and start to plot. Okay, using my standard equation of an ellipse, first denominator is a squared under the x, second denominator under the y is b squared for the vertical. I find that a squared is 5, so a is the square root of 5. B squared is 25, so b is 5. That means that my major axis is vertical. I plot my center of -3, +1, and I move horizontally the square root of 5, so that's bigger than 2 to the right, bigger than 2 to the left, up and down 5, up 5, down 5, and I get a vertically stretched major axis for that ellipse. Sometimes we call these the vertices at the end of the major axes. Alright, if I ask you to find the foci, are the foci going to be to the left and right of center or up and down from center? The foci are always on the major axes. That's how we form our ellipse. So I know the foci are going to go up, down. That tells me that the x-coordinate does not change. So the x-coordinate of my foci will stay at -3. But what are the y-coordinates of my foci going to be? To find the foci, I need to find C. Which of those Pythagorean theorems am I going to use? What's the biggest? A, B, or C in this ellipse? B is the biggest, so I'm going to use this version of the Pythagorean theorem. A squared plus c squared is equal to the largest, which is b squared. A squared was 5. I'm finding c squared. B squared is 25. That gives me c squared is equal to 20. And c is equal to, actually plus or minus, if I simplify that, square root of 4, square root of 5, 2 square roots of 5. So from the center, I'm going to move up 2 root 5 and down 2 root 5, wherever that ends up, to get those foci, F1 and F2. So where was I? At the center, I was at 1. I'm going to have to move up 2 square roots of 5. I was at 1, and down 2 square roots of 5. So I get some kind of messy foci there. 1 plus 2 root 5 and 1 minus 2 root 5. Alright, I'm going to pause again. I'm going to ask you to write the equation of this ellipse. Remember, you're going to need an A value, a B value, and a center. Center is not at the origin, so I'm going to plug into this. X minus h squared plus y minus k squared. First denominator, a squared. Second denominator under the y, b squared, equal to 1. Alright, and then we're going to find the ordered pairs for the foci of that ellipse. I'll pause so you can work through a bit. Okay, I found a center of 5, 2. I counted incorrectly in yesterday's notes. I'm so sorry. Thanks, Joey, for catching that. But here I have an A value, a horizontal distance of 6, a B value, vertical change of 4, and I'm going to plug into my standard equation, which is x minus 5 squared over a squared, which is 36, plus y minus 2 squared over b squared, which is 16, equal to 1, and I leave it like that. That's the standard equation of this ellipse. How would you find the foci? First of all, would the foci be up-down from center or left-right from center? Foci are always on the major axes. So the foci are going to be left-right of center somewhere, not necessarily plotted correctly, but the foci are going to be left-right. So if they're left-right, please notice that the y-coordinate will not change from the center, so that's 2 and 2. And now I have to find those x-coordinates. Stop for a second and find C. And I always think to myself, in this ellipse, what's biggest, A, B, or C? And that goes on the right of the Pythagorean theorem. What's the largest, A, B, or C value in that ellipse? And then solve for C. Okay, with a horizontal major axis, A is the largest between A, B, and C. A is the largest. So A stays on the right for the Pythagorean theorem, and I plug into b squared plus c squared is equal to a squared. b squared is 16 plus c squared is equal to 36. I get c is equal to plus or minus 2 root 5 again, but now I'm going left right of center, so I was at 5. I'm going to add 2 root 5, subtract 2 root 5. So the x coordinates will be 5 plus 2 root 5 and 5 minus 2 root 5. Okay, turn the page and let's read for a moment. Okay, I plotted my foci. Notice that right between the foci, this is the distance of C, is going to be my center. The foci are 8 units apart, so my center is 4 units below that focus. So I get a center for this ellipse at 2, negative 3, if I count 4 units down from that focus. Please notice that the foci lie on the major axis, so the major axis is vertical, and we're given the length of the minor axis is 6. So if the major axis is vertical, the minor axis is horizontal. If it has a length of 6, I must move 3 units to the left, 3 units to the right of center. So that must be my A value. So notice my A value is 3. My C value is 4. Take a moment, if you would, to find B. And that'll be up, down from center. Okay, with a vertical major axis, B is the biggest. So I'm going to use B squared is equal to A squared plus C squared. Plug in A squared and C squared, and I find that B is equal to 5. So to sketch this ellipse, I must go up 5 from center, down 5 from center, and then connect those points. And there's my vertically stretched ellipse. Okay, try this one. I'm a sketcher. I'm going to sketch that picture. Write the equation of an ellipse given the foci and a major axis of length 8. Please start that on your own. Okay, my sketch starts to look like this with my foci. The center will be right in between the two foci. So the the y coordinate does not change of negative 3. The x coordinate is right between negative 8 and negative 4, which will be negative 6. Gives me a center of negative 6, negative 3. Distance from center to focus is C. I always remember that because there's a C in the word focus. So that must be 2 units. So C is 2. Length of the major axis is 8. Here, the foci are on that major axis, which is horizontal. And I'm going to move to the right 4 and left 4 to give me a major axis of 8. So that means A is 4. And I need to find B. To find B, notice what's biggest in this ellipse. Since the major axis is horizontal, A is the biggest, and I'm going to use this version of the Pythagorean theorem, plug in to find B. Okay, please check. Since A squared is the biggest, I plugged in to find B. B squared is 12. That gives me that B is 2 square roots of 3. But I was really just asked to find the equation of this ellipse, so let me start plugging into my standard equation of an ellipse. And I get x minus negative 6 plus 6 squared over a squared, which is 16, plus y minus 3 squared. I really just needed b squared, which is 12, equal to 1. And that's the equation of my ellipse. All right, let's see. Write the following equation of an ellipse in standard form. Jot down standard form, which is x minus h squared over a squared plus y minus k squared over b squared equal to 1. How can we get that mess into standard form? Let me let you think for one moment. Okay, you'll remember from circles that we're going to have to collect my x terms together, my y terms together. I'll swing that constant over to the right. And you might start to notice we have to complete those squares. The problem is we never complete the squares with coefficients. So for an ellipse, I have to factor out that leading coefficient. What is that? X squared minus 4x, and then complete that square. Plus, factor out that 5. I wish we were together because you guys would have good suggestions for me on this one. Factor out that 5, y squared plus 6y, complete that square, equal to negative 36, balance. Okay, pause and complete those squares. I'm running out of time. Distribute, add 36, add 45. Take a look and divide to get equal to 1. Divide through by 45 and voila!